All right, so today we are moving on to multiplying and dividing rational expressions. So just a quick reminder of simplifying them. Remember that 4 over 6 is equal to 2 times 2 over 2 times 3, and then you can cancel the 2's, and you have 2/3, okay? That is good. If you have 4 over 6 and you have 2 plus 2 over 2 plus 4, and then you cancel the 2's, and then you get 2 over 4. This is not good, okay? No, 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 you can't do that, okay? Because if they're added, you can't cancel them. If they're multiplied, you can cancel, okay? So that brings us to the polynomials. If you have x plus 5 over x squared plus x minus 6, I cannot cancel this x with this x, okay? Because x is adding to 5, and this x is adding to x squared and adding to the negative 6. So you can't cancel that, okay? Please do not cancel like that. You cannot do that because these are stuck together, okay? So you can only cancel when they're multiplied, not when they're adding or subtracting. And that brings us to multiplying and dividing rational expressions. Here's example number 1. I have 2x plus 10 over x plus 4 times 3x plus 12 over 4x plus 20. Okay, so again, you can't cancel this x with that x, that 2 with that 4. You can't cancel anything right now, basically, because these are stuck together, and these are stuck together, these are stuck, and these are stuck. I'm telling you, every time you see things that are added together, or subtracted for that matter, you put parentheses around them, and you see them as one single thing. Okay, now, is there any one single thing that look exactly the same as the top and the bottom? No. So what we can do is, if they're multiplied together, guys, if they're multiplied together, you can put them next to each other. Okay, so like this 2x plus 10, and you combine them into one single big fraction. Okay, now they're all together, and it doesn't matter if it's in from two fractions. Oops, 4x plus 20. See, they're all together now. It's nice. What I can do now is I'm going to start factoring to make to see if they have anything that look the same as each other. Okay, so I'm going to take out 2 from this guy, top. I'm starting with this, okay? So I take out 2, I have x plus 5. And I'm going to take out a 3 from this guy, so I put a 3 here. See, they're all multiplied together. And you can cancel anything that's inside parentheses. So now I have x plus 4. And here I have x plus 4. I can't factor anything out of that, but I could factor something out here. I can take out a 4, I think. So now I have x plus 5. See? Now I can cancel anything inside parentheses. So like x plus 4 here, x plus 4, x plus 5, x plus 5. Now this 4 is actually 2 times 2, right? So that's 2 times 2. Now look at that. There you go. See, I can cancel that 2 with that 2. Now I have just 3 halves. All right, so let's go back. And remember, the cardinal rule for any simplifying is that you can only cancel if they're multiplied. See, I'm canceling now because these guys are just multiplying together because they're factors. I cannot cancel like the 2 with the 4 and the x with the x because they're adding to things. Okay, so remember that. And it won't always work out so nicely where everything is canceled, but a lot of times it will. Here's another example. I have 2x minus 6 over x squared plus 4x minus 5 times 4x minus 4 over x minus 3. See? I can't cancel this x with this x, okay? I can't cancel this 4 with this 4 because they're stuck like that. These are stuck, these are stuck, these are stuck, and these are stuck, okay? So put parentheses around them, put them all together in a nice one big fraction, like that. And this guy, it's a quadratic. It's not just a simple linear one anymore. All right, so now I'm going to have to factor to hopefully I can see things that are the same on top and bottom. So this guy, I can take out a 2. And I can also take out a 2 here. And I have x minus 2 left. At the bottom, I can factor this quadratic. That becomes x minus 5x plus 1. And here I have x minus 2. All right, so I have x minus 2 cancel with x minus 2. And then that's it. That's it. There's nothing else I can cancel. Interesting. So there's nothing else for me to cancel. This will be my final answer. That's it. Sometimes they might want you to multiply back in, but if it doesn't ask you to, you just leave it like this. Let's do another. I have 20 x minus 5x squared over x squared minus x times x squared plus 3x minus 4 over x squared minus 16. All right, you can't cancel this x squared with this x squared, okay? Can't cancel this x squared with that x squared. Do not do this, okay? If you do this, that is so bad. That is violating the cardinal rule, okay? Because these are subtracted. These are added. They're stuck. So put parentheses around them. Parentheses. Parentheses. All right, put them all together. Actually, I'm going to factor them all and then put them together. So I'm going to take out 5x from these guys. 5x. So that leaves me with 4 minus x. And then this guy, I'm going to factor that. That gives me x plus 4, x minus 1. And then this guy here, I can take out an x. And then I have x minus 1. And this guy is x minus 4, x plus 4. All right, so now I'm going to cancel x minus 4. Oh, no, man. X plus 4 and x plus 4 here. X minus 1 and x minus 1 here. And here I can cancel this x with this x because this is 5 times x. It's not added, so I can cancel separately. All right, so now I have 5 times 4 minus x over just x minus 4. And remember when I told you guys that if it's the same thing but opposite sign, you can just take out a -1. So now I have 5, and I take out a -1. If I take out a -1 from 4, I have -4, and the x is now a positive x. And here I have positive x and a -4. So now these are the same. They can cancel. So I have just 5 times -1 is -5. I'll do 2 more examples. Now I'm going to move to I'm going to move to division, okay? Because we multiplied already. So I'm going to multiply. Wait, what is talking about? We multiplied it already, so now I'm going to divide. All right, so I have x squared minus 4x minus 21 over 5x plus 15 divided by x squared plus 3x minus, what is that? 20? That's such bad handwriting. I can't even read my own handwriting right now. Let me just check. Oh, that's 70, not 20. So that should be a 70. All right. So a division. When you divide fraction, you guys remember how to do that? Dividing fraction means you just keep the first the same. All right, so I'm going to keep x squared minus 4x minus 21 over 5x plus 15. But I flip the second fraction and I make it multiply. So I put x squared minus 16 on top, and that guy goes to the bottom. So x squared plus 3x minus 70. And then you just do it like how you did multiplication. Okay, so I'm going to put it over here, put them all in the same fraction, top with top, bottom with bottom, and I factor this out. That one becomes x minus 7, x plus 3. And that's from this guy, all right? And then I factor this guy. That one becomes x minus 4, x plus 4. All right, that's from this guy. Remember, all you have to do is just flip the second fraction, and then you do the rest the same. And this one is just factor of 5. And then I have x plus 3. And I factor this. That becomes x plus 10, x minus 3, I believe. Let's see. Wait, minus 7. All right. And now I can cancel x plus 3 with x plus 3, x minus 7 with x minus 7. And that's it. That's it. That's all. So I have x minus 4, x plus 4 on top, and the bottom I have 5 times x plus 10. Done. I'll do one more division just to be sure. So 3x squared plus 13x minus 10, all of that over 6x squared divided by 3x squared minus 21. See, if you're dividing a fraction, just make this into a fraction. If it's not over anything, it's over 1. Right? So you just flip the second one. So now I have 3x squared plus 13x minus 10. Keep the first one the same. And flip the second one. So now I have 1 over 3x squared minus 21. And then you just factor things and put them together. So I factor the first one. Oh, do I have to factor this 3x? Oh, God, what is this going to be? 3 times 7 is 20. No, 3 times 3 is 3 times 2, 6. 3 times 5. Oh, 3 times 5. Positive 5 and negative 2. Okay. And the 1 is just there. I don't need that. In the bottom, I have 6 times x squared times 3 times x squared minus 7. Oh, this is 2x, not 21. So 2x. So I have to take out that x there. So I have 3x minus 2. Now there you go. Oof. Now that cancels with that. Now I have x plus 5 on top. And the bottom I have 6x cubed.